Okay, example 2 in section 2.4. And this is a really common example for this section, arranging repeating letters or letters in a word. So, and it's because, letters are obviously identical. There's no way to tell one A apart from another A. So there's less kind of interpretation in these problems than there is in if you have different physical objects that you know in your mind to be different. All right, so how many different ways can we arrange the letters in the word mathematics? First, we need to figure out how many objects it is that we're arranging. So how many letters are in our set? And if you count them out, there are 11 letters in the word mathematics. So now, next you want to find how many letters repeat. So start right at the front. So we have how many M's? 2 M's in the word mathematics. How many A's? There's 2 of those as well. T's? Well, we got 2 of those. How about H's? Only 1. E, there's only 1. Next letter I, there's only 1. C, there's 1, and S is 1. So you can work your way through the word like that when you're doing these problems. That might be helpful. And then you want to set up your equation. So we know we're using n factorial divided by a factorial, b factorial, however many on the bottom. You want to set up what you have. So you have your n objects on top. So we have 11 factorial in our numerator. And we're going to divide by the number of times that we get some repeating objects. So there's 2 M's, there's 2 A's, there's 2 T's. Just like that, or arrangements of our repeating objects, rather. And we'll work that out to be, so 11 factorial is, and this is going to be one of those numbers where it's starting to get close to the limits of what your calculators are going to do. So we could simplify 11 factorial a little bit. We can cut off one of the 2 factorials, but I don't know if that's really going to help us here. So we're going to divide all of that by 2 factorial times 2 factorial times 2 factorial, which is 8. And that gives us so 4,989,600 ways to arrange those letters.